Okay, so we have examples of determinants. What is the determinant of this matrix that's a row of x's and then two copies of 0, 0, x?
0.
Why?
Because you have two linearly dependent columns.
Good.
And rows.
Yeah. This is going to be clearly not invertible because it has linearly dependent rows. Great. Next. How do you calculate this one?
You could do cofactor or you could do this.
Yeah, I'd probably do the cofactor on this one. So, since there's no zeros anywhere, there's no really intelligent choices to be made.
Yeah.
So you just go, alright, it's going to be 1 times the determinant of a little matrix minus 2 times the determinant of a little matrix plus 3 times the determinant of another little matrix. And then we need to just go through and cover up. So, for 1, we cover up the first row, first column.
Yeah.
And so we get 5, 6, 8, 9. And then for 2, we cover up first row, second column. So we get 4, 6, 7, 9.
Yes.
And for 3, we cover up first row, third column.
Yeah.
Get 4, 5, 7, 8.
Fuck. I realized what I did. No, I didn't. No.
Okay. And then in each of these, we need to multiply. So I have in this first one, 5 times 9 minus 8 times 6
That results in 45
is
minus 48.
45 minus 48, all times 1.
Yep.
Then we're subtracting 2, and here we're going to have 36 minus 42, and here we're going to have plus 3 times
32 minus 35.
32 minus 35.
This is what I got. Like, oh my God.
And let's see, a little arithmetic yields, we have minus 3,
Minus 12.
and
Plus 12.
36 minus 42 is negative 6, times negative 2 is plus 12. And here we have 3 times 32 minus 35 is negative 3.
What? Oh, yeah. That
So I have negative 9.
And you get 0.
And I get 0.
But I put it in my calculator and it's invertible. I chose the bottom row. I also did the bottom row and I got 0.
So, what may have happened here? Either we screwed up some arithmetic, right? Or you put it in your calculator wrong.
I got the same thing.
You got 0?
Yeah.
Yeah, okay. So
Everybody got 0?
I did put it. Oh, I put 3,
So,
5, 6. Yeah.
Let me think about this a little bit.
Now that's, yeah. Okay. I put it in.
Okay. Are these columns obviously linearly dependent?
Yeah.
What do you mean, yeah? Shut up,
Oh.
O'Ryan.
Oh, no, yeah, I see it.
What do you mean, oh no, yeah, I see it? What do you got? Where's your obvious?
Top row, side, right column.
What?
Never mind.
How is it obviously linearly dependent?
Well, what you could do is you could just... I don't know.
I don't know. I don't know what I'm doing.
It's obvious.
It just
It's
feels
obvious. You can just tell.
It just feels obvious. Okay.
Well, you know,
Okay,
you multiply the first column by 2, you don't the second column.
You're just doing the old guess and check.
Yeah, like, I don't know that these are obviously linear, like, these don't seem obviously linearly dependent to me.
I guess you could just. Like,
But apparently they are.
you can ref it. Plug it in.
Yeah, we could reduce it, right?
And
that's where we would see that linear dependence come into play.
And the right side would be zeros. And then, yeah, you can just get.
Okay, how about this one?
I got C.
You got C.
Yes.
Yeah.
How'd you
Okay,
do that?
How did I do that?
Yeah.
I did the cofactor at first.
You picked the bottom row?
Yeah,
Okay.
I also did that.
You also did the bottom row? Why didn't you guys pick the row with the C in it? Okay.
Oh wait. Yeah, that's easier. What? What am I doing?
You can pick whatever row you want. It shouldn't matter at all. So I just need to pick a row and label plus and minuses. Since you guys picked the bottom row, I'll pick the row with C and we'll see if we get the same thing.
Okay.
Right? So I just need to make my little checkerboard of plus
I
minuses, right?
did pick the row and C in it and didn't realize. I was like, that's not a shit ton of zeros. But I didn't think about it. I just
You guys with me?
Yeah.
So I checkerboarded just the row I needed, right? So I'm going to use this row.
Yep.
So I'm going to have 0 times the determinant of some crap minus 0 times the determinant of some crap plus c times the determinant of some crap
Plus determinants.
minus 0 times the determinant of some crap.
All of that stuff's here, right?
Yeah, so these ones I don't even need to figure out what this stuff is.
And then you plug in the matrix and you get I. for C.
So in C, I need to cover, right?
You get I.
So I get the identity matrix. So I get C.
Yeah.
Cool. Kick ass. Way to be right, guys.
The the reason I said like, oh, I could have just done the first method that computers do, multiply the pivots. I'm not a computer. I know I'm not a computer.
Well, so
but
you can just multiply the pivots, but notice this doesn't have a pivot yet. You guys see that? So you could reduce this one step. You could say, okay, I'm going to multiply row 3 by d over c and subtract that from row 4. Because it's got a 0 here, it's not going to change this. Or sorry, it's not going to change the 1. It'll just remove the d.
Yeah.
And then you could multiply the pivots.
Okay.
But be careful with that method, because if you're going to calculate a determinant by multiplying the pivots, you need to actually have the pivots.
Okay. Well,
Cool. And the ref in your calculator divides all the rows, so it loses the pivots. With me?
so ref, not row ref.
I believe that ref in the TI-83 calculator also divides the rows, but I could be wrong.